Happy National Don't Cry Over Spilled Milk Day. It is also National Latte Day. It's also National Be Alone Day. And there's one other like crazy one today, and so we decided Don't Cry Over Spilled Milk Day was the one that we were going to go with today. Also, it is Test Eve. Okay, so tomorrow is your test. As I stated numerous times to numerous classes. I'll wait. Because you probably want to listen to the next words that are coming out of my mouth. Okay? As I've stated numerous times in numerous classes, your test tomorrow is 4 sides long, okay? But it is only 6 total questions. Okay? So it's 6 questions and 1 extra credit, and the extra credit takes up an entire page, so it gets its own page tomorrow. So there's 2 problems per page, or 2 problems per side, and then the extra credit has its own side. Okay? All right. There will be 4 solving of the triangles, 2 word problems, and then the extra credit is a word problem too. So, okay. They're spaced out enough that you have enough room to work in between the problems. But there is answer blanks for you to fill out again like normal. So that just kind of keeps it nice and easier for us. Okay. Any other questions regarding the test? I didn't get to it in the last class, but I will definitely get to it sometime at this class. The information that is on the back board of the things that you should know, and the front board with the law of cosines, those will be erased. And we're back after being so rudely interrupted. So that's tomorrow. So we're going to start, again, the numbering system. If you're looking back there and you're like, okay, Liz, why are we going to 4.8 from 5.6 and then going to 6.1? That numbering system is from our old textbook. And so section 4.8 dealt with some navigation angles. We decided not to do that section until right now, because then we can directly apply it to the vectors that we're going to use here momentarily. Okay? So this week, obviously, is test, and then today you're going to learn 3 different ways to name an angle, and then we're going to put it to use in a couple of word problems. Okay? On Friday, you're going to learn a 4th way to name the same angle. Okay? And so there's going to be 4 different ways, and there are 4 different usages of those 4 different ways today and Friday. Then next week we'll start vectors, and then we'll test the 3rd of March. I had to look back there and see. Okay. So we are starting with navigation today. So far, up until this point, we've been using the unit circle for our angles. Okay? And so when we use the unit circle, oops, that didn't help. Helps to get onto the right color. So when we're dealing with trig or the unit circle, okay, we have 0 degrees, 0 radians straight out to the right. And then we go 90 up top, 180 to the left, 270 on the bottom, 360, and so on and so forth. And that's our way that we go around. Okay? And that's great and all for trig. That's great and all for unit circle. Okay? However, if we are in navigation, use this all the time, I'm guessing. Okay? In navigation, 0 is measured from the north. So in nav angles, north is straight up, so that becomes your new 0 degrees for just navigation angles. Okay? And then positive angles are drawn clockwise. So east would come next, it is 90 degrees. South would come next, it is 180 degrees. West comes last, it is 270 degrees. Now that's navigation angles. Those angles will be given to you in the problem at the start, and that's the style that you're going to have to give at the end. In the middle comes trig. So if you're going to use a trigonometric function, you have to convert your navigation angle into a trig angle. Or if you're using a triangle to solve it, if you're using SOHCAHTOA or something like that, then you got to deal with reference angles. So the three ways to name the same angle today are by its navigation, by its trig or unit circle, and by its reference angle. Okay? So with that being said, let's do a couple of examples, and then I'll have you do a couple of examples just to see how we both do on them. So we're going to say that these are navigation angles. Oops, I should tap the brakes here. I wanted to do this. These are navigation angles. Okay? So a 53-degree navigation angle would be here. Zero is at the top, and we go clockwise around the circle. So that would be my 53-degree navigation angle. Probably going to be easiest to find the reference angle next. My reference angle comes off of the horizontal and goes to the angle. So what would my reference angle be for this one? 37 degrees. Since this angle ends up being in quadrant number 1, my reference angle is also my trig or my unit circle angle, which then would also be 37 degrees and be right here. Okay? Let's expand our horizons, and let's expand where we're going. So 195-degree angle, I would start straight north, come down to east is 90, down to south is 180, so I'd have 15 more degrees to go to get my 195-degree navigation angle. So I know that this angle here is 15 degrees. Okay. What would my reference angle be? What would my reference angle be? Nope. 75 degrees. Yep. Reference angles are acute. They come off of the horizontal. So my reference angle here would be 75 degrees. What would my trig or unit circle angle be? Trig or unit circle angle? 255 degrees. Questions, comments, concerns, clarifications? Okay. These were both navigation angles. Or do you want one of them to be a unit circle angle? No? Okay, let's go both navigation angles. Find me the trig angle. Find me the reference angle for both of them, please. So a 300-degree navigation angle would be there. Which would give me a trig angle or a unit circle angle as 150 degrees and a reference angle of 30 degrees. So my reference angle would be there and my trig unit circle angle would be there. Okay. $127-degree navigation angle puts me down here. Would give me a 37, oops, that's the wrong color, that's pink. Would give me a 37-degree reference angle. Would give me a 323 trig angle. Agree? Questions about that? Okay. So, one of the things that we're going to be talking about, or that we're getting into, is we're going to be flying a lot of planes, and we're going to be sailing a lot of ships. Okay? Because we're going to get into vectors. And with both of those, it's not just straight line, okay? If you've ever flown on a plane before, or if you've ever piloted a plane before, you get up in the air, and there's other forces that act upon you. And so that's what we're going to get to. We're going to get to wind and current and all that fun stuff acting upon whichever vessel we are traveling in, okay? For right now, we're going to assume no wind, no current, none of those extra things that go on. Okay? So, on land, it's called miles. Okay? Right? And that's fairly standard. 5,280 feet is a mile, etc., etc., etc. Okay? It was actually, the mile was actually developed from 1,000 paces back in the Roman times And then in 1592, the English Parliament said, we're going to make a mile be 8 furlongs. And a furlong, and trust me, this is some of the useless knowledge that I have up in my brain. Okay, a furlong is 660 feet. That's where 5,280 feet came from then for a mile. Okay, now on the water, it's different. On the water, it's called a nautical mile. Okay, and so a nautical mile is based on the circumference of the Earth. Okay, if we cut the Earth at the equator into 360 individual equal pieces, that gives us 1 degree of the equator. Okay? Then we take that 1 degree and we cut that into 60 equal pieces. That gives us 1 minute of the equator. And a nautical mile is 1 minute of arc on the equator. Okay? Okay? So that ends up being, because of we know the distance of the equator, and we know that we have to divide by 360, and we know we have to divide by 60, that ends up being, in the English measurement system, 1 nautical mile is 1.1508 land miles. Okay? Or approximately 6,076 feet. Okay? Now I say all that just so that I can say what a knot is. Okay? A knot is not something that you tie your shoelaces into. Okay? A knot for us is nautical miles per hour. Okay? So it's how far a ship travels in 1 hour. So if you ever hear that a ship is sailing at 23 knots, that means that the ship is doing 23 nautical miles every hour. Okay? For instance, today, we're going to say a speedboat is traveling at 40 knots from Fort Lauderdale. Okay? Now, let me scroll down here a little bit more, and let me get Fort Lauderdale here into view. That's our speedboat, by the way. I want you to know that. Okay? So a speedboat is traveling from Fort Lauderdale at 40 knots. I believe it was on a course of 55 degrees, or a bearing of 55 degrees. Side note, a course of 65 degrees is saying that that's a navigation angle. Bearing of 65 degrees is saying that's a navigation angle. Okay? So course, bearing, all those different things are navigation angles. Okay? So it's on a course of 65 degrees from Fort Lauderdale. Which means then that this angle right here is 65 degrees. Okay. It travels on that course at 40 knots for 2 hours. How far has that boat traveled? Not 80 knots, 80 nautical miles. Yep. The symbol for nautical miles is NM. I know, shocking. Nautical miles, the symbol is NM. Okay. All right? Everybody with me so far? Yes. So now our boat is out here somewhere in the middle by Bermuda. Okay? A little bit short of Bermuda. Okay? Then it said that the boat changes to a course of 155 degrees. So now our boat has changed course and now our boat is traveling on a course of 155 degrees. So that means that this angle here now is 155 degrees. It travels on that course for 4 hours. How long or how far has it traveled? 160 nautical miles. Knots is speed. Okay. Nautical miles is distance. What? Oh, it sounded like you said knots. We want to find the distance that the boat is. So now the boat is down here. Here is Fort Lauderdale. We want to find the distance the boat is from Fort Lauderdale and the bearing that you would have to take from Fort Lauderdale to get to the boat. So let's say I went out on a boat and my bestie Super decided to leave an hour and a half after me, and so he's just going to go right to where I'm going to be. Okay? All right? So we need to find this distance. And then we also need to find this angle. Okay? We have to find the brown distance to the boat. Let's call that D. And we need to find this angle here. Let's call that theta. Okay? So, what do we know? Let's go through what we all know. If we know that this red angle right here is 65 degrees, how much is this green angle right there? 25 degrees? If I know that that red angle right there is 65 degrees, how much is this red angle right there? Why? Alternate interior angles. Yep. I would also know then that this angle here is 25 degrees, again, by alternate interior angles. Okay? If I know that this angle here is 155 degrees, what is this pink angle right there? 25 also? Okay. Is that helpful to us? Yes, because now we have a right triangle now. Okay? All right, we now have a right triangle. That's a good thing. Okay? So how can we find side length D? Pythagorean theorem. Okay? So the Pythagorean theorem says that D squared is equal to 80 squared plus 160 squared. 80 squared is 6,400. 160 squared is 25,600. all told, d squared then is 32,000. So side length D just itself then would be agree with me on that?
Yes.
Okay. In terms of theta, we know that this part of theta is 65 degrees. We don't know this part of theta because this 25 doesn't include the whole angle. So what can we do to find this angle? Let's go purple. I want to find this angle right here. I'll call it beta. How can we find beta? How can I find beta?
Inverse tangent of 160 over.
SOHCAHTOA? Okay. So the tangent of beta is going to be the opposite side, which is 160, over the adjacent side, which is 80. So beta is going to equal the inverse tangent of 2. I get beta here is 63.4349.
4882.
49.
Yeah.
Okay. So what is the bearing? Okay. So in terms of our answers, the boat is 178.885 nautical miles on a bearing, or on a course, if you will, because it was course in the problem, on a course of 128.435 degrees from Fort Lauderdale. Oops, I forgot of. Questions, comments, concerns, clarifications?
How many miles space is this?
The what?
Based off this, to get that one.
Because the speed is the speed is how many nautical miles it's doing per hour. And it told us in the problem that on the red side it was going for 2 hours, on the blue side it was going for 4 hours.
Yeah, I just don't know how you get the measures. Yeah, I know.
So it's going 40 nautical miles for 2 hours. That means the first hour it went 40 knots for 2 hours. So in the first hour it went 40 nautical miles, and the second hour it went 40 nautical miles. So when a total of 80 nautical miles. And if I had told you, ladies and gentlemen, you are being very rude, I will say it. I will say it out loud. You have been very rude this entire class. Prove me wrong. If you were driving in a car, okay, and I said that you were driving 60 miles an hour, and you drove for 3 hours, how would you figure out how far you went? Same thing. Knots is a speed, time is a length of time. Multiply them together gives you the distance. Yep. Okay. A shoreline is running north and south, and a boat is due west of the shoreline. The bearings of the boat from 2 points 300 feet apart on shore are 240 and 260 degrees. We want to know how far the boat is from shore. So that's the distance right there that we are looking for in the end. We have 2 bearings from 2 different points. And those 2 points are 300 feet apart. I'll label them just for sake of helping us out as point A and point B. Which one, point A or point B, has the 240 degree bearing? A? Mm-hmm. A has the 240 degree. If you think about it, as this red line, I'll use the red line as an example. As this red line gets closer and closer and closer to the horizontal distance that the boat is, that angle in there expands, which means that that bearing is getting bigger and bigger and bigger. Or that, yes, we said bearing in this one. That bearing is getting bigger and bigger and bigger. Okay? So that means that this one down here is 260 degrees. With that being said, what is this pink angle inside there? Pink angle inside there. 60. What is this purple angle inside here? 80. With that being said, what is this black angle right here? 100. With that being said, what is this third angle of the triangle? We'll also put in black. No. Be 20. Okay. Let me break out our triangle. We know that this is 60. We know that this is 100. We know that this is 20. And we know that this is 300. Do you want to find red or blue first? Red? Red? Okay, we'll find red first. Okay? If we are going to find our red side, let's call it X. If we're going to find our red side, what am I going to use? Law of science? Okay, set it up for me. Sine of 20 over 300. Agree? Find me what X is. I get 759.626666. Yes? Okay. All right. So now we have this side length. What can you tell me about a north-south shoreline and a east-west distance line? Makes a right angle. Okay. If this purple angle in this right triangle is 80 degrees, what is this green angle here in that triangle? 10 degrees. Okay. So now we have a right triangle. That looks like this with an 80-degree angle here, a 10-degree angle here, and it is a right triangle. And we know that this side length is 759.626666. We need to find this distance, correct? What would we use? SOHCAHTOA, which one? Sine of 80 would be d over 759. What's our other option? Cosine of 10. Okay? So it doesn't matter which one you use. I heard sine of 80 first. So I get 748.086,230. So the boat is 748.086 feet offshore. Questions, comments, concerns, clarifications? Again, I remind you that today is test eve. Okay? That tomorrow you have a homework packet that is due for 5.5 and 5.6. That you have 2 formative corrections that are due from 5.5 to 5.6. And there are 2 of them in that unit. Okay?